Hello and welcome everyone, and thank you for joining this session. In this session, we have Professor Keri Colabroy from the department from Chemistry Division at Muhlenberg College. And in this video, we are going to learn about what the structure of the academic curriculum of chemistry and biochemistry program is like. We are going to learn about what are the different concentrations within chemistry and biochemistry. Then Professor Colabroy will share with us about what are the kind of students who would do well in the chemistry major or in this field. Then we'll listen about the typical career options upon graduation, and finally we'll hear her comments on the future trends. So before moving forward, let me quickly introduce Professor Colabroy. Professor Colabroy is the Professor of Chemistry and the co-director of Biochemistry program at Muhlenberg College. A very warm welcome to you, Professor, and thank you so much for joining this session today. I'm excited to learn about chemistry and biochemistry, and over to you now.
Thank you so much. I've been at Muhlenberg for 16 years. So I've taught over 120 majors that have graduated and gone on and done all kinds of amazing things. So I'm excited to tell you about our program.
Fantastic. So maybe we can start off by you telling us a little bit about how a chemistry major and a biochemistry major is structured across the 4 years in an undergraduate program.
Awesome. I'd be happy to do that. So a chemistry major is, as you might expect, has less biology in it. So a chemistry major is going to start with general chemistry and math, calculus 1 and 2, and then we'll progress to organic chemistry. The first 2 years are relatively straightforward and have a pretty traditional regimen. If you're a biochemistry major, those first 2 years will include 3 semesters of biology, 2 semesters of math, and the 2 semesters of Gen Chem and 2 semesters of organic chemistry, which is why so many biochemistry majors are thinking about medical school, because it actually combines all of the classes you need to go to medical school in the United States. So after that, the second 2 years, what we call the junior and the senior years, are more flexible. In the chemistry major, you might take things like analytical chemistry 1 and 2, physical chemistry 1 and 2. You could take inorganic chemistry. You could pick up some electives. But in biochemistry, it's even more flexible because the courses do not go in a 1-2 pattern. You can take experimental biochemistry, advanced biochemistry, introductory biochemistry. So all 3 of those courses are accessible in different orders, which is why lots of biochemistry majors also choose to study abroad.
Okay, that's fantastic. Tell us a little bit about what are the different concentrations within chemistry and within biochemistry, and what are these concentrations or classes these students can take?
Mm-hmm. So we are a liberal arts college, which means we don't necessarily favor concentrations like you might find at a bigger university. So you're going to get a pretty broad-based chemistry or biochemistry major. That being said, inside the chemistry major, you find that students like to choose electives, for example, in environmental science and toxicology. So they might have interest in chemical ecology or environmental science, and they kind of choose their electives in that direction. You have students that are really interested in instrumentation and love using all of the equipment. So they push their electives in that direction, like robotics or NMR. In biochemistry, you find that the electives swing towards the biology side or the chemistry side. And so I have students that really want to do more molecular biology and they choose electives in that direction, or students that really want to do more physical biochemistry and they choose their electives in that direction.
Okay, perfect. That's great information. Okay, so do tell us a little bit about what are the skills that students should work upon during their high schools if they're planning to take one of the majors like chemistry or biochemistry. And along with that, what are certain traits of students that you generally see succeeding in the chemistry major?
That's a great question. So when students ask me about a biochemistry or chemistry major, the first thing I'm going to ask about is your mathematics preparation. So you having the most high school math that you can is an advantage, especially going all the way to calculus. Calculus in the United States, we call them advanced placement classes. I don't know what they're called in your country, but something similar where you are doing calculus in high school. Then when you get here, you would take a placement test, and we find that successful chemistry and biochemistry majors place easily into calculus, usually into the second semester of calculus. So we're looking for mathematics preparation. That would be the number one factor for success in those early courses. After that, we're really looking for students that want to be in the lab, that want to be doing experiments, that can be okay with dealing with a little ambiguity and some frustration and things not always working the first time. So if you enjoy cooking in the kitchen and experimenting with how a dish might come together, you might actually be a chemist. And so we're looking for students that want to be in the lab. We're also looking for students that can spend the time. A chemistry major or biochemistry major has more hours than another major like history, right? Because you're spending more hours in the laboratory. And lots of times that means at the advanced levels in the third and fourth year of college, students are making choices to be in the lab over doing something else. So it pays off in the end, but that's the kind of student that we're looking for.
Wonderful. And another trait I would add is someone who is okay with exceptions, because there are a lot of exceptional rules, like there are rules and then there are exceptions to the rules in chemistry. So someone who is okay in handling those exceptions. Okay, that brings me to my next question, and that is, what are some of the typical career options that you see students pursuing upon graduation? You can talk about like jobs as well as postgraduate courses that you see them doing.
Awesome. So the good news is that chemistry and biochemistry majors are incredibly successful. You work very hard to be a chemistry or a biochemistry major, but it will pay off and you will be very successful. So that's the bonus. First, let me address students that go into the workforce. Students that go directly into the workforce are working in places like industry, in the laboratories, doing science at the bench for companies like a laboratory or a pharmaceutical company or a biotechnology company. So that is certainly possible. We've also had students do things as diverse as data analytics. And I've had students go into business after the fact, take their biochemistry major, and several years later get an MBA and are now in business. So all of those are options. That is certainly a minority of our students. Most of our students are going to choose postgraduate education. And that's because a chemistry major, you can actually really raise your income earning potential if you get some graduate degrees. And so we have students doing master's, PhDs. Those would be considered traditional graduate degrees. Most of our students will do PhDs. A handful do master's degrees. Those PhD programs that they get into are the absolute top PhD programs in the world. So our students are incredibly successful. We've sent students to the top 10 PhD programs every year since I've been here. So that's exciting. When you do a PhD in the United States, that means you get to do research and take coursework at a high level and then complete a dissertation, and you'll be a doctor at the end of that. There's another category of students that choose what we call in the United States professional school. These are schools that are medical professions like dentists, optometrists, medical doctors, doctors of osteopathy, physical therapists that do health professions. So those are professional schools, and we send about 60% of our biochemistry majors go to professional school. So they become physicians or physical therapists or something like that, and those students are also very successful. Most of those schools that they attend are in the northeastern corner of the United States, because that's where we're located, but they're also very successful in those endeavors as well. Some schools that they've attended recently are like the University of Pennsylvania, Thomas Jefferson University, Drexel University in professional school. Some graduate school options that we've recently sent students to are Princeton University, Texas A&M University. Sorry, I'm trying to think. So those are some typical ones. University of Pennsylvania, that's another one.
Fantastic. That's really wonderful. Professor, I'm almost coming towards the end of my questionnaire. I have two more questions for you. The first one is, would you like to share a little bit about your research, or what are you working on, or what are your favorite fields within chemistry and biochemistry?
So it's actually a great question, because one and the same, research is both essential and the future of the chemistry and biochemistry majors. So 30 years ago, when I was a student, to do research before you went to graduate school was not terribly common. Nowadays, everybody is doing research. And if you want the most competitive positions, if you want an industry job after graduation, you must do research while you are an undergraduate. We understand that here. Our faculty are research active. That means that you can do research. Over 90% of chemistry majors do research before they graduate. Biochemistry majors, the number is lower because so many of them become physicians, but it's still above 70%. So that means getting research is important for your future, and we understand that. My own personal research is in enzymology. That means I study enzymes and I study how they do their chemistry. I'm particularly interested in enzymes that do difficult chemistry that we can't otherwise accomplish in the laboratory. And I'm particularly interested in enzymes that take regular old materials and turn them into something really useful, like a drug or an antibiotic, a natural product. So the enzymes I work on right now take kind of the stuff of tree bark, which we might know is in lignin is the chemical name for it, and turn it into something useful, in this case, an antibiotic. So we're studying those enzymes at the molecular level using chemical tools and asking chemical questions. But I have colleagues that are designing drugs. I have colleagues that are designing organometallic catalysts. I have colleagues that are using lasers. I have colleagues that are doing microfluidics. So all of those are options. In the biology side of things, we have folks that do research in molecular biology, in plants, in model organisms. We have neuroscientists that are doing their research in the membrane. So all of those are options if you're a chemistry or biochemistry major.
Wow, that's really fantastic to hear. Okay, so this brings me to my final question now, and that is, what are your comments on the future trends? Where do you see chemistry and biochemistry going in the next 5 to 10 years? And because these students, they are going to go to the college next year, and once they graduate, that's probably 5 years from now. So what do these students expect?
All of chemistry and biochemistry is becoming more interdisciplinary. So again, 30 years ago, you could take just chemistry classes and be okay. Nowadays, a chemistry major has to know about biology. A biochemistry major has to know about physics. There is a lot of crosstalk between the disciplines, and the extent to which you can integrate and work across disciplinary lines will determine how successful you are. That's why I think a liberal arts college like Muhlenberg is so powerful, because we are integrated at our very core. You're not taking chemistry in isolation. You're taking chemistry in conversation with all of the other disciplines. So this is where things like green chemistry, which is really the future, where we're doing chemistry in an environmentally friendly way. Well, that's already environmental science, biology, and chemistry cross-talking. And so we have an expert on green chemistry here on our faculty. So these kinds of interdisciplinary projects can't be done if you're only learning chemistry just all by yourself, right? You have to be talking across boundaries. And that's why I think our students are so successful, because they are prepared for the next, what is the future of this interdisciplinary language that we're seeing take over.
Wow, that's fantastic. Really, I mean, the approach of thinking interdisciplinary, don't think just chemistry, think about mechanical engineering, think about psychology. I don't know. I mean, think about music and chemistry. I mean, there would possibly be some way people can merge music and chemistry. Yeah.
You are absolutely correct. We have many students that are double majors. I have a colleague down the hall doing neuroscience of perception, which is a fusion of biochemistry, neuroscience, and psychology, right? So this is real. In order to answer questions, interesting questions that often have impacts on human health, you have to work across boundaries.
Yes, fantastic. Thank you so much, Professor Colabroy. It was a pleasure connecting with you, hearing about chemistry and biochemistry. And I am really taking back some fantastic points. And we'll add these video on YouTube very soon, and I'll share the link with you. And you can expect some of these students who are excited about chemistry and biochemistry to connect with you and to learn more about you and Muhlenberg College. With that, let me just share with all the people who are watching this that Muhlenberg College is a Next Genius partner college, which means that if you're applying to Muhlenberg, you have access to Next Genius scholarships. To learn more about that, check out our website, which is next-genius.com, and you can apply for full tuition scholarships at Muhlenberg. Once again, thank you so much, Professor, for joining us today. It was a pleasure speaking with you, and I look forward to connecting with you sometime again in the future.
Thank you so much. It was lovely to talk with you. Have a great day.
Great.